In Module 4, we will cover the intricacies of neuroscience of sleep. You will learn about cutting-edge neuroscience developments in understanding the crucial functions that occur in each of the stages of the sleep cycle, in addition to the detrimental results of sleep deprivation. Knowledge will also be shared to provide guidance in developing revolutionary sleep hygiene habits to achieve restorative neuro nights required for health, happiness, and performance throughout life.
We live in a sleep-deprived society. In our busy lives, sleep either isn't prioritized or adequate sleep isn't able to be achieved. Humans spend approximately 1/3 of our life asleep. And to invest 1/3 of our life towards one function, sleep must be vital to survival. On average, we sleep 1 hour less per night now than we did in the 1940s. Understanding what happens during sleep and how vital this function is can empower change and prioritization. To understand the benefits of sleep, we need to first understand exactly what happens while we are sleeping. Our sleep experiences many different stages and many cycles of each stage. Each stage has a clear purpose, and in recent years, with neuroscience developments, we are learning significant insights into the powerful functions occurring during specific stages of sleep. There are two main types of sleep: rapid eye movement, known as REM, and non-rapid eye movement, known as non-REM. Non-REM sleep includes 3 stages: light sleep, deeper sleep, and our deepest sleep, also known as slow wave sleep. Let's take a look at the stages of the sleep cycle on this diagram. We have the stages of the sleep cycle on the left, and on the bottom we have time, which shows 5 cycles occurring throughout the night of sleep. Firstly, we can see the 5 experiences of REM throughout the night. Of note, the duration of REM for the most part increases as sleep progresses. Next, we have non-REM 1, our light sleep, which is only activated at sleep onset or after moments of waking during the night. In non-REM 2, our deeper sleep is achieved on the journey to non-REM 3, which is our deepest sleep and known as slow wave sleep. Of note, the duration of slow wave sleep is longer earlier in the sleep cycle and reduces in duration as sleep progresses. Let's take a look at the stages of the sleep cycle in more detail and understand exactly what's happening in our brain and bodies during each of these stages. In non-REM 1 light sleep, this is our transition from wakefulness to sleep onset. It is our lightest stage of sleep, where we experience increases in electrical activity in the brain and higher brainwave amplitude. There is increased synchronicity throughout the brain, with neurons firing together in sync. We are easily woken in light sleep, and light sleep constitutes approximately 5% of our sleep. In non-REM 2 deeper sleep, our body temperature begins to drop, our heart rate begins to slow, and our brain begins to produce sleep spindles, which are rapid bursts of rhythmic brain activity. Approximately 45 to 50% of our sleep is in deeper sleep. And in non-REM 3, slow wave, it's our deepest sleep. Our brain experiences high amplitude, slow brain waves, known as delta waves. There is a high degree of synchronicity throughout the brain, with neurons firing together, pausing, and firing again. Our muscles through our body begin to relax, our blood pressure drops, and our breathing rate drops as well. Slow wave sleep constitutes approximately 25% of our sleep. And we have REM sleep, iconically known for its eye movements in a rapid motion. We experience an increased rate of respiration. Our body becomes relaxed and immobilized as our muscles are paralyzed. Brain activity looks very similar to awake time, although slightly more active. There's less synchronicity in brain waves and in neurons. We experience dreaming in our REM sleep. REM sleep constitutes approximately 20 to 25% of our sleep. And we have learned that neurogenesis occurs during REM sleep. Let's take note of some key features of the sleep cycle. The stages of the cycle alternate repetitively throughout sleep. Each cycle can last from 90 to 120 minutes. Depending on the length of sleep, you can achieve 4 to 5 cycles. Non-REM 3 slow wave sleep lasts longer during the earlier cycles of sleep. And REM sleep lasts longer as sleep cycles progress. Our first REM cycle lasts approximately only 10 minutes. However, our fifth REM stage can last approximately 1 hour. So we learnt that neurogenesis occurs during REM sleep. And between approximately 7 to 8 hours of sleep, we experience an optimal window of approximately 1 hour of REM. So by obtaining 8 hours of sleep and being able to access this powerful boost to neurogenesis as often as possible, you will be optimizing your neurogenesis potential and in turn, all of the health and well-being benefits we have discussed. What actually happens while we sleep? We used to think while we slept, our brains also rested. This couldn't be further from the truth. We now understand that while sleeping, our consciousness is offline, yet our subconscious is more active than while we are awake. 3 key functions that occur while we sleep include maintaining a healthy brain, synaptic pruning, and learning and memory functions, which we'll be taking a look at in more detail. During sleep, our brain undertakes housekeeping, conducted by glial cells, who remove toxins from the brain. Like gardeners for the brain, glial cells turn over the soil, improving signal speed of neurotransmitter communication. To allow for the glial cells to clean the brain, neurons shrink in size and the space between cells expands by up to 60%. This process allows the glial cells to flood the brain with cerebrospinal fluid, flushing out neurotoxins. This process primarily occurs during non-REM stage 3 slow wave deep sleep. In this image, we can see the cerebrospinal fluid in blue flooding the brain during sleep to clean out neurotoxins. One particular neurotoxin removed by glial cells is called beta amyloid. Buildup of beta amyloid is linked to formations of plaques in the brain, predictive of cognitive and memory impairment. Significant buildup can result in Alzheimer's disease. Beta amyloid is linked to cell death and deterioration of the cortex. So we want to flush beta amyloid out of the brain, and without sufficient sleep, beta amyloid grows. beta amyloid is cleansed from the brain twice as effectively while we are sleeping. And certain neurological disorders may be preventable or treatable by optimizing the lymphatic system's ability to clean neurotoxins during sleep. We only learnt about these housekeeping processes in the brain in 2012. So this is relatively new information and vitally important to integrating a focus on prioritizing quality sleep to promoting health and well-being throughout the lifespan. Adenosine is another compound cleansed from our brain by our glial cells while we sleep. It is created naturally within the body. Adenosine is like a sleep pressure that builds up throughout the day, creating a feeling of sleepiness. We have learnt that caffeine bonds to the same receptors as adenosine, essentially tricking the brain into thinking it's not tired. So while caffeine may reduce the feeling of tiredness, it comes at a cost of interfering with your sleep cycle and the quality of sleep and restoration you achieve. Caffeine consumed 6 hours before sleep can lead to a measurable loss of 1 hour of sleep quality. So even if you're achieving 8 hours of sleep, you may only be gaining the restorative effects of 7 hours. Tolerance to the alertness enhancing effects of caffeine develop quickly, requiring higher doses to achieve the desired feeling. The recommendation is that we cease caffeine intake 8 hours before sleep to allow our brain to be cleansed from caffeine and free to achieve optimal sleep and restoration. Consider this. If we fall asleep every day with caffeine still in our system, it comes at a cost. If we're having caffeine in the afternoon, we could be reducing the effectiveness of our sleep by up to 1 hour each day. Multiply that by a year, and we're looking at approximately 15 full days of effective loss of restoration of sleep. So how valuable is time? And how important is that coffee or that caffeinated soft drink? Another vital function of sleep is synaptic pruning. This involves the microglial cells, the gardeners of the brain, making room by removing neural pathways no longer needed or used. The intricacies of synaptic pruning is an ongoing area of research. We know connections less often used are marked by proteins which microglial cells bond to, and in turn, these connections are pruned. What we focus our attention on, actions we repeat, or feelings we experience regularly, are protected from synaptic pruning as these neural pathways are ingrained. So by focusing our attention on something, a thought, feeling, emotion, new habit, or goal, we are protecting the associated neural pathways from being marked with these proteins and in turn removed by microglial cells. This knowledge makes sense of the compromising effects of rumination when we become fixated and lost in a focus on negative thoughts, feelings, or experiences, and also makes sense of the healing influences of therapeutic techniques aimed at focusing attentional awareness on desired outcomes, hopes, and strengths. Sleep is vital for learning and forming new memories. While we sleep, our subconscious reviews everything we have been consciously aware of and even input our subconscious has picked up on throughout the entire day. Things we have seen, heard, smelt, tasted, touched, and even our thoughts. Sleep is not only vital in essentially pressing save on memories created during the day, but we also need sleep prior to learning to prepare the brain to soak up new information. Without adequate sleep, memory circuits are unable to absorb new memories. Think of sleep's learning and memory functions as twofold, both retaining information already received and creating space to integrate new learnings proactively in the coming day. The hippocampus is a key brain structure involved in memory, working like our mind's inbox. Our hippocampus can receive new memory files and hold on to them. With quality sleep, the hippocampus lights up with healthy learning-related activity. Sleep deprivation shuts down our memory's inbox, essentially bouncing back incoming input unable to be processed. We just mentioned that during sleep, we are processing information that we consciously notice during the day and also information our subconscious stored. While we sleep, our subconscious looks for connections or patterns to make sense of information that may not have been consciously processed during the day. During slow wave non-REM 3, the brain lights up as it processes sensory input from the day, demonstrating a replay-like function of sleep. Information is replayed 10 times faster than normal speed, with the ability to fast forward, rewind, and skip throughout the day. REM sleep is played out in normal speed, as our dreams follow a linear sequence of events. In a study on how we identify patterns, after receiving training on a topic, some participants slept prior to being tested for their recall. Those participants that slept between training and testing achieved 2.5 times improved performance compared to those that were tested after training. This research reinforces subconscious insights being developed during sleep. Another study measured humans' brain activity while navigating a maze in a video game. Participants then slept in a scanner where their brainwaves were measured during non-REM 3 slow wave sleep. Activity in their hippocampus was recorded to be similar to while they were awake navigating the maze in the video game. It was found that increased activity in the hippocampus during sleep predicted improved ability to navigate the maze the next day. These findings are important as they help us understand the powerful functions of sleep and how our subconscious makes connections and assists in learning even while we sleep. Sleep enhances our quality of memory. Powerful brainwaves occur during deep stages of sleep. These bursts of brain activity transfer information from a vulnerable short-term memory circuit to a more protected and safe long-term memory pathway. It's like backing up our phone's data to an online storage, so the fragile device isn't holding all your information. With the knowledge we have learnt, let's take another look at the sleep cycle. We have learnt that REM sleep, the red line on the chart, increases in duration as sleep progresses. It is during REM sleep that neurogenesis occurs, and we have a powerful window of approximately 1 hour of REM between 7 to 8 hours of sleep. We have also learned that during non-REM 3 slow wave sleep, our deepest sleep, that it lasts longer during earlier stages of sleep. And this is when housekeeping occurs, with our brains being cleaned of neurotoxins by our glial cells. And memory processing also occurs in this stage. So how much sleep is enough? Are you one of the 5% of the population with a genetic mutation requiring only 6 hours of sleep to experience restoration? Probably not, as 95% of us aren't. Sleep deprivation makes you feel hungrier, lose muscle, and reduces the ability to lose fat. We experience higher ghrelin levels, which is a hormone causing us to retain fat and feel hungry. After one night of poor sleep, we can experience a 15% increase in ghrelin. We have less leptin, which is a satiety hormone helping us feel satiated, so we're not so hungry. We have less melatonin, which is a powerful cancer treatment and has anti-aging properties. Melatonin also helps us to burn fat. We experience increases in cortisol. As we learned earlier, residual cortisol can increase visceral fat around our organs. And cortisol promotes your body to break down muscle into fuel, known as gluconeogenesis. Sleep deprivation also results in less human growth hormone, HGH, which is the youth hormone stimulating growth and cell reproduction and regeneration. We want as much HGH developed naturally in our system as possible. As HGH increases muscle and reduces fat, it improves skin elasticity, improves cognitive function, and a deficiency in HGH can lead to depression. Research has found that being asleep between 10 p.m. and 2 a.m. is the greatest period of production of HGH. Let's take a look at how sleep deprivation impacts the functioning of the amygdala. Remember earlier in the program, we learnt the amygdala is our brain's threat detector, and with excess stress, our amygdala becomes physically enlarged, overactive, and inaccurate at detecting threat. In a study of healthy adults comparing limiting sleep to 6 hours per night for a week with achieving 8 hours of sleep per night for a week, the sleep deprivation group were observed to have 711 genes distorted in their activity. Genes that were decreased in activity are genes that are required to protect our system, and genes that were increased in activity due to sleep deprivation were associated with the promotion of tumours, long-term chronic inflammation, stress, and cardiovascular disease. In this image, we can see the participants who experienced sleep deprivation had much greater activity in their amygdala compared to those that were able to achieve adequate sleep. We have also learnt that sleep deprivation compromises our emotional stability, guiding our brain to focus on negative thoughts, feelings, and memories. We interpret situations more negatively, overreact, feel irritable, less cooperative, more aggressive, and are more likely to fight with our partner, children, families, colleagues, and friends. Sleep deprivation causes neurons to fire more weakly and slows down their response time, making them function less effectively. Neurons in our prefrontal cortex, located behind the forehead, slow down when lacking sleep, impacting planning, personality expression, decision-making, attention control, reasoning, and problem-solving ability. Without adequate sleep, our brain is unable to adjust to effectively engage in problem solving, and a whole night without sleep results in a 40% reduction in our ability to learn. Moderate sleep deprivation, involving 17 to 19 hours consecutively awake, can result in side effects equating to 0.05% blood alcohol content. After 4 days of 5 hours sleep per night, you're effectively too drunk to drive. And after 14 days of 6 hours sleep per night, it's the equivalent of staying up for an entire night. Prolonged sleep deprivation erodes the fabric of life, our DNA, altering the function of genes at the level of gene expression, increasing risk of disease. Less sleep results in a less effective brain and a less healthy body. As sleep reduces, we experience less productivity, less creativity, less patience, and poorer communication. Reading from a tablet in the evening compared to a book has negative impacts on the quality of restoration achieved from sleep. Nighttime technology use and screen light exposure results in less melatonin production, less quality REM sleep, taking longer to fall asleep, feeling less sleepy at night, and feeling more tired the next day, even with 8 hours of sleep. How does naturally produced cortisol work in the body? Cortisol secretion is involved in our circadian rhythm. Cortisol levels reach a natural base level about midnight if we are asleep before 10 p.m. Levels begin to rise 2 to 3 hours after sleep onset. There is a natural peak about 30 minutes after waking, and then a gradual decline throughout the day to support sleep patterns. Higher cortisol levels before sleep result in decreased slow-wave non-REM 3 and increased light sleep non-REM 1, as well as frequent waking. Insufficient sleep also increases our stress response system, our HPA axis activity, creating a vicious cycle. Strategies to stabilize stress response activity decrease cortisol production and are beneficial in treating insomnia and sleep disturbances. Staying up late when your body expects you to be asleep also increases cortisol levels. And lacking sleep and interruptions to sleep raise cortisol levels the following day. We have learnt how important quality sleep is and how sleep deprivation takes a significant toll on our mind, body, and overall well-being. We all want to achieve quality sleep, so let's take a look at some strategies to help in optimizing our sleep. Routine. Going to bed at the same time and waking up at the same time every day creates routine. Routines anchor your sleep and improves quality and quantity of sleep. Avoid eating 3 hours before sleep. Pre-sleep routine. Establish a pre-sleep routine that always follows the same sequence. Creating more anchors associated with sleep allows the brain to gradually prepare the mind and body to wind down. For instance, have dinner, take a shower, brush your teeth, watch a calming TV show, take a break from technology, perhaps read a book. Lights become dimmed and you go to bed. Circadian rhythm. The buildup of adenosine during the day develops a sleep pressure. Melatonin production increases at night, leading to a sleep window. The sleep window can be out of alignment due to caffeine, unstable sleep schedule, or light stimulation. Bedroom for sleep. Your brain loves to make associations, and if it only associates the bedroom with sleep, your going into the bedroom will be associated with going to sleep. Keep technology out of the bedroom. Consider this concept for children's bedrooms and the stimulation of toys being out and available. The only exception is intimacy. Lights and screens. The light-dark cycle perceived by our eye is a regulator of our biological clock. Our eyes have photosensitive retinal ganglion cells, which are highly sensitive to light. Screens' blue light suppresses melatonin, the sleep hormone, and increases cortisol levels. This light is as alarming to our eyes as a dog's bark is to our ears. Having a dark bedroom. Dark blockout blinds and eye masks can be helpful in reducing exposure to light to help sleep in. However, our skin has the same light-sensitive chemical, rhodopsin, as in our retina, and our skin can essentially detect light, impacting on our quality of sleep. The temperature of our room. We sleep better in cooler environments. Our body temperature drops to help us sleep. We can take a cold shower or bath to cool down the body. A warm bath also helps, as the body rapidly cools afterwards, although allow about 30 minutes before sleep to allow the body to cool adequately. Our sleep position. The side lateral sleeping position is the most popular in humans and animals in the wild. Using too many pillows hyperextend the neck, and a worn-out mattress doesn't provide support for the curvature of the spine. The side sleeping position reduces sleep apnea, improves quality of sleep, and helps glial cells clean the brain more easily. Avoid sleep medication. Sleep medication compromises naturalistic sleep. Self-medication through alcohol or other substances also compromises naturalistic sleep. You may be able to fall asleep, but the quality of sleep and the duration of REM cycles are jeopardized. Avoid caffeine. The half-life of caffeine is complex and dose-dependent and can last up to 9 hours in our system. Caffeine in your system when you sleep compromises the quality of sleep, even if you're able to fall asleep after that evening coffee. The recommendation is for a maximum dose of 200 milligrams of caffeine per day, and the suggestion is to have no caffeine after lunch. Avoiding naps. Naps during the day reduce the sleep pressure buildup, adenosine. If you're having trouble falling asleep at night or sleeping 8 hours, try avoiding naps. While naps can have mild restorative benefits, the 7 to 8 hour sleep window is optimal for neurogenesis due to that 1 hour period of REM at the end of that cycle. Tossing and turning. If you are struggling to fall asleep, get out of bed and do something different. If you stay in bed reading, watching TV, worrying about your sleep, your brain will associate the bed with wakefulness and only return to bed when you are sleepy. Let's take a look at some additional information about sleep. We receive a daily dose of cortisol in the morning to help us wake up and activate our body and mind, and melatonin increases in the evening to support sleep. We can reset our body clock through morning sun exposure, ideally between 6 a.m. and 8 a.m. This may be able to assist for experiences of jet lag. Think of sleep like a dimmer, not a light switch. It is a gradual process you ease into. Falling asleep can take about 20 minutes. Avoid watching the clock, as you secrete more cortisol doing this due to triggering stress. Focus thoughts away from to-do lists, worries, or frustrations from your day, as these can lead to rumination. Yoga, stretching, or back rolling can help loosen the spine before sleep to improve quality of restoration during sleep. Sleeping 5 hours per night can reduce our reproductive system. Men's testosterone levels can be equivalent to that of someone 10 years their senior with sleep deprivation. As part of our biology, we have natural killer cells, which are a type of lymphocyte. They can be referred to as the secret service of our body. They identify dangerous compounds in our system and remove them quickly. For example, cancer cells. Sleep deprivation of one single night of only 4 hours sleep has seen a reduction in killer cells by up to 70%. The good news is that after one night of sufficient sleep, these killer cells return to full functioning. We want a fully functioning, optimized arsenal of elite killer cells to promptly detect and remove threats from our system. Night shift work has been identified by the World Health Organization as a probable cause and risk factor for many types of cancers. The World Health Organization classified night shift work as a possible carcinogen due to the impaired sleep cycles. Sleep isn't just important, it is vital. The shorter we sleep, the shorter our lifespan is. As we age, our sleep patterns change. A physiological trait of aging is our sleep deteriorates and memory declines. Slow wave sleep reduces as we age. It is common to experience no slow wave sleep from 65 years of age. And without slow wave sleep, we are missing the vital functions of learning and memory, in addition to cleaning neurotoxins from the brain. There is current research into optimizing sleep, aiming to restore and enhance sleep for aging populations. Let's take a look at some examples of how we are aiming to improve the quality of sleep as we age. Firstly, sleep engineering, which involves playing certain sound frequencies at particular stages of sleep and has been found to improve the quality of sleep. Preventative treatments in the future are aiming to maintain slow wave sleep as we age and in turn slow down cognitive decline. There is also direct brain stimulation involving small voltage to the brain, so small that we can't feel it, but it has measurable impacts. This provides the ability to amplify the size of deep sleep brain waves and doubles the benefits on memory from sleep. Future hopes involve the ability to salvage memory and learning functions for aging populations and dementia patients. There is a global experiment occurring twice a year with 1.6 billion people across 70 countries. It's daylight savings, and we're about to look at some of the research on what sleep deprivation of a change in 1 hour can result in. When we lose 1 hour, there is a 24% increase in heart attacks the next day, and a similar percent increase in car accidents and suicide rates. When we gain 1 hour back, we see a 21% reduction in heart attacks the next day, and again, a similar percent reduction in car accidents and suicide rates. Changes in sleeping patterns, quantity and quality of sleep has a significant impact on our well-being.
Take some time to think about your sleep habits. What is working well? What have you learned that may be compromising the quality of your sleep? Aim for more neuro nights where you achieve optimal restorative sleep without caffeine or substances in your system, and by gradually reducing light exposure and sensory stimulation as you approach sleep. Create a pre-sleep routine that sets you up for success.